Hello. So what we got over here on the left is our can. The volume is going to be pi times the radius squared times h. I want to solve that for h, so I don't have to deal with the square root, basically. I could have solved it for r, but... So we know that the volume is going to be 250 cubic centimeters. So h is going to equal 250 divided by pi times r squared. Surface area for a cylinder is 2 pi rh plus 2 pi r squared. Pi r squared is going to be the area of the top and the bottom. 2 pi rh is the lateral area of the cylinder. Well, we've got two different costs for the top and the bottom, so I separated those out. So the cost of this thing is going to be 4 cents, 0.04, times the surface area, that's the area of the sides, plus the area of the bottom. So we get 0.04 times 2 pi rh plus pi r squared, plus the cost of the top, which is 0.07 pi r squared. Now we can substitute in for the h, and we get c equals 0.04 times 2 pi r times 250 over pi r squared plus pi r squared plus 0.07 pi r squared. Then I guess we can distribute the 0.04. The pi's are going to cancel out. I'm going to have 1 r down here. So I'm going to have 0.04 times 2 times 250. That's 20. So this is going to equal 20 over r plus 0.04 pi r squared plus 0.07 pi r squared. I can combine like terms here. So this is going to be 20 over r plus 0.11 pi r squared. So that's our cost function right there. So to find the minimum, we need to do the derivative of this. Well, it'll help us if we change this to 20 times r to the -1 power plus 0.11 pi r squared. So c, the derivative of c is going to equal -20 r to the -2 power plus 0.22 pi r. And I can rewrite that as -20 over r squared plus 0.22 pi r. Now to find the minimum, we want to set that equal to 0. So now I got 0 equals -20 over r squared plus 0.22 pi r. It's easier just to leave the pi in there until the very end. So then we'll add 20 r over r squared to both sides, equal 0.22 pi r. Well, we'll multiply both sides by r squared, and I get 20 equals 0.22 pi r cubed. Then we'll divide both sides by 0.22 pi. Now we'll do the pi. 20 divided by 0.22 divided by second pi. So this equals 28 0.9. I'll get us plenty of decimal places here, so we got something to play with. That equals r squared, r cubed. So now we want the cube root of that. That comes out to be 3.070 centimeters. Will equal r. Then we'll plug that back into my r here to get h. So now we got 250 divided by pi times 3.070 squared equals h. So I'll square that number, take it times pi equals, and we'll do reciprocal times 250, and that comes out, h is 8.443 centimeters. So there you go. We had to use the information they gave us for the volume to be able to write h in terms of r. Then we did the surface area. Then we did the cost function based on that. Then we substituted in for the r. Okay. Multiplied that all out and got 20 over r plus 0.11 pi r squared was the cost function. Then we took the derivative of that, set it equal to 0, and we got the radius was 3.070 centimeters, and the height of the can was 8.443 centimeters.